Hey everybody, today I'm doing another problem, and the problem is number 15 on 2.2 on this book. The book says our first course in differential equations with modeling applications, right? So we do in this problem, and we doing by separation of variables, and we following this format, right? And we using the convention that if an equation is in this form, is separable. Okay, so how can we prove that this is separable? Well, I'm going to separate. I have dy over dx is equal to g of x times h of y. In other words, I have a derivative on this side, and the derivative is equal to two functions on the other side, right? So, and I have to separate this. I want to put the dy with the function of y, and I want to put the dx with the function of x, and I'm going to kind of separate this by multiplying across by dx, and I get dy equal g of x times h of y dx, right? Now I'm going to divide both sides by h of y, alright? If I divide both sides by h of y, I get, okay, those cancel each other out, alright? And I get dy over h of y equaled g of x dx. See, now this is already separated, right? I already separated the variables. I have dy over h of y equal g of x dx, right? So I'm going to solve this problem, this differential equations, which is number 15 on 2.2, right? And I have dx over dr is equal to kx, right? So now I have a derivative, and then I have a function of x on the other side, but I have like a k acting like a constant. So k is basically a number. In this case, you know, you can think it as a number. So what I'm going to do, this is what I'm going to do right here. I'm going to multiply by dr on both sides, right? And I'm going to go ahead and multiply by dr, and I get dx. I'm sorry. ds equal to ks dr, right? Now notice that I am going to separate the variables, and I can leave the k right here. I don't have to divide by k. I could, but it's going to do nothing pretty much, not gonna make any difference. I could divide by k, and it's not gonna make any difference in this problem. So I'm gonna go ahead and just divide by s, right? And I get ds is equal to ds over s is equal to k dr, right? Now it's separated. Now the next step is integration on both sides, right? So when I integrate on both sides, I get ln absolute value of, I'm sorry, I'm dealing with s, and I'm thinking that I'm dealing with x. So absolute value of x of s, right, is equal to k dr, I'm sorry, I am integrating, I'm sorry, kr plus c, right? So in order to get rid of this ln, I have to take the e on both sides, right? Take the e on both sides, alright? And this becomes, when I take the e on both sides, this becomes s equal e to the k r plus e to the c, right? Now notice that I have two bases, so this can be written as s is equal to c times e to the k r, right? That is the solution for this problem, right? Thank you for watching, and I hope this helps somebody who is taking a differential equation course, and of course is doing separation of variables, right? So that's the section where this problem is at number 15 in that book. Alright, so I hope this helped anyone who is taking differential equation. Thank you for watching.